YouTube channel on socially engaged philosophy. We philosophers who are running this channel, we want to address relevant contemporary social political issues from philosophical perspectives. If you have an issue on which you would like philosophers to give you a spectrum of views, then please let us know and we might be able to do something about it. Now, our first topic is closely related to the two big issues of today: the ongoing corona crisis and, of course, the climate crisis. We want to explore commonalities and differences between the two issues. Needless to say, the topic is vast, and we can only here touch upon a few selected aspects. And the one aspect that we have decided to focus on is that in both cases, scientific expertise or scientific knowledge play a central role, and that in both cases, we all, whether we are scientists, philosophers, or lay people, have to form views on whom to count as scientific experts and what to count as reliable scientific knowledge. Now, with me today is Alex Reutlinger, a philosopher of science from LMU Munich, who has thought long and hard about these issues. Hello, Alex.
Hi, Mark.
Martin Kusch, a philosopher from the University of Vienna. Alex, would you like to give us a little overview on how you see the issue we want to explore together?
Yeah, sure. Thanks, Martin, and thanks for having this discussion with me today. So I think what we could focus on is that kind of in both crises that you mentioned, in the corona crisis and in the climate crisis, there is something strikingly common. Yeah, so citizens and also politicians, they kind of have to make up their mind about what they think about science in general, about specific scientific claims, also about individuals, about alleged or real scientific experts. So in all of these senses, they have to make up their mind or form an opinion, an informed opinion about science. And I think why people, us, all citizens have to form such opinions is because in both crises, we have to make well-informed and responsible decisions. Yeah, and those are pretty unspectacular everyday decisions, like should we book another flight? Is that good for the climate? Yeah, should we wear a mask in the supermarket when we go out currently? Should we also wear it elsewhere or not? What are the reasons for and against that? Or kind of, if you look at that more generally, are we in favor of certain policies that are meant to prevent certain harm in both crises? Yeah, these questions is what we're facing. And I think in general, making these decisions and forming an opinion about scientific matters runs into two important problems. So the first one is most people are not scientific experts. And even if they are, they might not be scientific experts in the relevant sciences that are crucial in both crises. And the second point, I think, or the second obstacle for making a decision is that when you want to make up your mind about a piece of science or scientific information, you have to deal with conflicting claims about the sciences or that particular piece of scientific information. You have to form an opinion about certain criticisms of science. And I think it would be a nice topic for us to talk about this second point rather than the issue of expertise in great detail. That is to talk about different categories and kinds of science criticism that we find in public debates, particularly in different media. And I think as philosophers of science, we might have something interesting to say about this for other people. So I think thinking about this is really a key issue if you want to come to well-informed and responsible decisions in these times.
Yes, that that makes a lot of sense to me. Are there some different main categories or kinds of such criticisms? Is it possible to somehow categorize them, put them in distinct boxes, as it were?
Yeah, I think, or at least that's the proposal, right? That we or what we can talk about, and I will make some proposals of this kind. There are certain categories of science criticism that might be useful or not. That's something to discuss for the two of us. But my idea here is not that I already have it done. Yeah, that I have a complete and perfect set of concepts or categories that we should use, but it's something to discuss, and maybe in the end we need more categories than I have proposed originally, or maybe less, or maybe different ones. That's something for us to find out, and maybe we know better by the end of our conversation. I hope it.
Okay.
Yeah.
No objections. So please let us hear your first category then.
Right. So first category, and this is no particular order, but the first category is maybe just to open up a sort of conceptual space of distinctions here. Yeah. So you might imagine some critics of science just being people who are against science whatsoever. They are against science across the board in every form, in every detail. They reject science entirely. Yeah, and you could talk about these people as being members of the anti-science brigade or something like that. And I suspect, admittedly, this is not a large group of people, because even people who have pretty stern negative views about science, they still here and there positively rely or embrace certain aspects of science or its technological applications. I mean, they at least use their phones, is what I'm saying.
I see.
Yeah.
So the first category, if I understand it correctly, is like mainly of interest as like an extreme case, that even though it's not very often that one finds such people, still as a case, it throws some interesting light on other less radical cases. And of course, I mean, even though one doesn't find, as you rightly say, those sorts of people in today's world very often, of course, if we go back in cultural history of ideas, history of philosophy, history of religion, of course, one sometimes do find people and sects that are skeptical of science per se, because they think that scientific curiosity about the natural world is somehow curiosity misplaced, and one should rather devote one's life to prayer or religion and not be concerned with the natural world. So at least we can sort of make sense of what such type of position might look like. But let's set it aside and move on to your second.
That's right. I mean, it's just a way to get going, right? And I think the next three categories I'd like to propose, they are a bit more useful, to understand the current crises. But having this first category in mind helps us to understand the other three, I think. Yeah. So the what's about to come now, these further categories, they're not wholesale rejections of science, but instead they are, well, in some sense, they are criticisms that take place within science. Yeah, and we have to distinguish different kinds of criticisms inside of science. So first, or let's say the second category and the first criticism within science, that is something one encounters in so-called scientific revolutions. And scientific revolutions were in the history of science cases of very fundamental, very radical disagreements, and therefore also very fundamental and very radical criticisms between different scientists. So that's another fairly extreme but intra-scientific sort of science criticism. What do you think about this, Martin?
Yeah, and one can easily make sense of that, say, in terms of the Copernican Revolution, perhaps the most famous of all scientific revolutions. After all, it involved giving up pretty fundamental beliefs about the Earth being at the center of the universe, or that every object has its natural place towards which it strives, or then that our innate perceptual organs, our eyes, our ears, do not need to be improved by any instruments, and of course many other views. So clearly this is an interesting case of scientific disagreement and criticism. Why do you think it is still of interest today? I mean, how does it compare to the sort of criticisms we find in COVID-19 or in the climate crisis?
Well, I mean, I think it's sort of indirectly relevant to the case we look at in these two crises, because certain critics of science today present themselves as the revolutionaries in in those historical cases of scientific revolutions. Yeah, and therefore, thanks for helping me out with a nice example of a scientific revolution, the Copernican Revolution. So if you look at this particular example, historians and philosophers of science, they have analyzed the deep disagreements in that case and many other revolutions between scientific revolutionaries and their counterparts, so to speak, the defenders of the old physics, the old chemistry, or the old biology, or what have you. And kind of from the perspective of the kind of defenders of the old view, what the revolutionaries are saying sounds crazy and absurd. In the case you mentioned, to them, it's just absurd to think that the Earth could not be at the center of the universe. Yeah, but for the revolutionaries, the opposite is true. Yeah, they think of the old guard, so to speak, as holding a crazy, outdated, biased, and prejudiced view of the universe and on our solar system in that particular example. Yeah, but I think a lot of this has been said in the context of the history and philosophy of science, but getting into the details of revolutions, I think that takes us too far afield right now, I think. Yeah.
So, yeah, I understand. So would you say that in today's world of COVID-19 and climate science, there are revolutionary changes and criticisms that involve such attacks among scientists that are somehow reminiscent of scientific revolutions?
No, I personally don't think that's the case. So I think none of the relevant sciences if you usually kind of a revolution is preceded by a sort of crisis, certain problems, theoretical or practical, experimental problems cannot be solved in a science. The science gets in a crisis and then a revolutionary phase breaks out. I don't see any of this in the relevant sciences, in climate science or in epidemiology or virology or other medical sciences. It rather seems to me, it seems to be the case that certain critics of science, whatever their motives really are, they want to give the impression to a wider audience that we are in a revolutionary phase when it comes to, for instance, climate science. But it seems to me they say so in order to discredit climate science and other sciences publicly.
Mm-hmm. Yeah, I see that it's a bit difficult to squeeze climate science or epidemiology or virology into the standard model of how scientific revolutions take place. Absolutely. On the other hand, one might say that the emergence of climate science as this peculiar combination or mix of very different sciences, from astronomy to computer science, economics to mathematics, meteorology to oceanography, physics to political science, that this radical mix is something new. And funnily enough, it's often said in scientific revolutions that between the old guard and the revolutionaries, there is a phase of incomprehension where neither side really fully understands what the other side is doing, that one finds a certain kind of peculiar incomprehension nowadays within climate science, given that such different sciences are involved in producing different bits of the overall calculation of the future climate. Historians and philosophers and sociologists studying climate science have been struck by these expressions of lack of understanding of the other scientists involved in the same calculation. So I agree with you that this is not a case of a standard scientific revolution, but one can say that and still say there is something also quite radically new about these modern sciences that both science critics and science defenders, in a way, have to struggle with.
That's right. I mean, that's something we can certainly agree on. There are these interesting and perhaps radically novel features in climate science. They have something to do with a kind of very strongly divided workload among different disciplines. They have to do with models that not everyone can easily access from each discipline. That's fine, and those are interesting challenges, but I think it's different to talk about these challenges from calling them revolutions or saying that climate science is in a revolutionary phase, which somehow suggests to me, and I think that's what people want to suggest who claim that there's something unsettled, something not quite mature, something too uncertain about climate science. And I think the danger is too high to talk about revolutions in this context, but to rather talk about what you have mentioned just a second ago. Yeah. Mm-hmm.
Yeah, so it may also be that there's a bit of an interesting difference actually here, since we also wanted to explore a bit differences between the two cases, between the COVID-19 situation and the climate science case, because climate science really is in its structure and in its deeply interdisciplinary and transdisciplinary character something quite new in the history of science. Whereas, for all I know, epidemiology and virology are not such a radical mix and therefore don't quite have the same level of complexity and internal incomprehension as we find in the case of climate science. So maybe there's an interesting difference in these two cases. If I may also make a suggestion myself, it seems to me that climate science critics sometimes refer to its enormous complexity as a reason for distrusting it. You know, how can you trust it if it's so terribly complicated? And the very difficulty of getting one's head around climate science may well sometimes be a cause for why some people end up distrusting it. Not to forget that the sheer number of scientists, the thousands of scientists involved in producing, say, a report of the Intergovernmental Panel on Climate Change truly is mind-boggling. This type of criticism, it's so complex, this criticism, is not yet, it seems to me, much found amongst critics of epidemiology. Its models and theories are also pretty complex, hence epidemiologists disagree often in their forecasts. They are pretty complex too, but not to the same scale so far as climate science. If I may, I'd like to add one more interesting connection between scientific revolutions and the current situation, something you already briefly mentioned in passing. I mean the fact that critics of both climate science and epidemiology often borrow the mantle of the revolutionary from Galileo Galilei, the famous defender of the Copernican worldview. In Austria, for example, we have a gynecologist fighting against mainstream medical advice on social distancing, and he explicitly likes to present himself as a misunderstood genius akin to Galileo. And I've seen the Wall Street Journal, always on the warpath against climate science, presenting climate change deniers in pretty much the same way. I don't want to belabor this point too much, though it is worth stressing that the comparison between Galileo and these modern-day revolutionaries is not really convincing. One reason it's not convincing is that Galileo was not the lonely figure fighting against a consensus view. Astronomy at the time of Galileo had no such consensus view. Not to forget that Galileo made scientific claims largely in his own scientific specialty, whereas a gynecologist commenting on epidemiology is not commenting on something in his own specialty.
Thanks, Martin. I think that's a very good point to mention and to describe how this historical figure of Galileo is used in today's debates, and I think that's certainly the case. But my suggestion would be that we move on and talk a bit about other types of science criticisms or modes of critiquing science that we find in the current public debate, if that's okay with you.
Mm-hmm. Yeah.
All right. So just to quickly to recap, so we talked about two kinds, right? The first being these members or the critics that are members of the anti-science brigade, so people who are just against science, period. Yeah. So that was one kind. Another kind was what we've talked about at length now, criticisms and disagreements of a particular sort that you find in the context of various scientific revolutions in the history of science. Yeah? Mm-hmm. Let me now get or propose a third category that might be useful to classify what you find in different public debates. Yeah, so the third one is something one could call, well, it's just ordinary science criticism, something you find in the daily work, the daily business of, well, every working scientist. Yeah, it's about scientists criticizing each other, trying to improve their work in different contexts or with respect to certain aspects to improve precisions of measurement or precisions of prediction. And they do so by reviewing each other's work. They point out certain mistakes, they suggest improvements, and something like that. And there's a name for all of this, or one name for all of this, and that is, well, the peer reviewing process when it comes to publishing scientific work, and that certainly involves criticism of the kind I just described. Yeah, and here I think it's a very important point to make is that the purpose of the criticism in peer review or in this ordinary science criticism is to improve scientific work. It plays the role of quality checks, I would say.
Mm-hmm. I was wondering, listening to you, whether such ordinary science criticism has to come only from inside the scientific specialty in question, or whether it can also come from other disciplines, or even from outside of science altogether. In asking this question, I'm reminded of an anecdote that I think I once heard from the sociologist Harry Collins about the physics of gravitational waves. Namely, that the community of physicists working on this topic once got a letter from a medical doctor challenging the statistics used by these physicists to make their predictions. The physicists looked at this criticism of this lay person in physics, thought this was quite interesting, invited him to a talk, and then in response to his talk actually changed the way they used their statistics.
That's right. I mean, I would say what we called this ordinary science criticism, I think a standard case is certainly that the criticism comes from other experts in the same discipline. Yeah, but I mean, since you mentioned these radically new features of climate scientific research, there certainly are more and more fields where the investigation involves people, experts from different disciplines. And I mean, in these areas, certainly the pool of peer reviewers, of your ordinary critics, so to speak, also comes not just from one discipline. Yeah, so that's certainly the case. And as you said, there are examples where outsiders, scientific outsiders, not just disciplinary outsiders, have a positive impact or make a good criticism of work in a particular scientific discipline. Yeah. But one shouldn't forget that although this does take place, it's certainly not what always happens, that non-scientists come to scientists and utter one useful criticism after the other. So one important or one kind of very common example is, so if you talk to colleagues in the physics department, even if I talk to my colleagues in Munich who work in philosophy of science or philosophy of physics, they get emails on a regular basis from people who send them long letters disproving Einstein's theory of relativity. So I'm assuming these people aren't all physicists and don't work in physics departments usually. And a lot of these emails, of course, either rest on misunderstandings of Einstein's theory, or they utter criticisms that have already been addressed in the physics community. That's at least what my colleagues tell me, what these emails are like. Luckily, I don't get many of them. And what I wanted to say, and what I agree with you upon, is that in many, many cases, these criticisms of lay people, they are sincere. Yeah, they are conducted with a lot of respect for scientific methods and more generally some sort of scientific spirit. So that's in that sense, they are also criticisms within science.
Mm-hmm. Yes, these critics coming from outside the science, at least outside the scientific specialty in question, is of course something one does indeed find in both the COVID case and in the climate case. The Austrian gynecologist I mentioned a moment ago, so he's attacking epidemiology, a field in which he's not expert at all. Something the same can be said for one of the leading climate science skeptics, Stephen McIntyre, who actually is a mining consultant, not a climate scientist. And mining is not generally an essential part of climate science. So there's also a jump from one scientific discipline to another. So listening to you, it seems to me that in the category of ordinary science critic, we have a number of different cases. We have scientists engaging in peer review in their own discipline. We have scientists criticizing work in other specialties, in their own field or in another field. And we have laypersons criticizing scientific work in ways that are almost indistinguishable from the way scientists in the respective field criticize each other. And of course, all of these criticisms may sometimes be successful and sometimes be unsuccessful. That's why it seems to me that this third category is particularly difficult to handle for all of us who are part of the science public, because it is hard to detect that the critics are not competent when they behave pretty much like ordinary scientists do. And it is hard to rule out that even non-experts might sometimes come up with a really good ordinary criticism of science, like was the case of the medical doctor vis-a-vis the physics of gravitational waves. But okay, have we now covered all of the possible forms of science criticism?
No, I think I want to add one last one, if that's all right. So one that I think is particularly useful in the context of the two crises we talk about is criticism of science understood as something one might call strategic science skepticism. And a strategic science skepticism involves a certain kind of critic, namely critics that on the one hand seem to be, or say they are, very much in favor of science and the rules of conduct in science and scientific methods and so on. But on the other hand, these same critics basically very selectively contest or deny certain well-established, empirically well-established scientific claims or results. And they do so, if you look at them from the outside, so to speak, they do so to promote certain non-scientific interests, namely certain economic or political interests. And there is the two historians, Naomi Oreskes and Eric Conway, they have a nice phrase for that. I think it's not their phrase, if I remember correctly, but they use it a lot. They speak of that as fighting science with science. And I think that's a very good way of describing this phenomenon in an intuitive way. But let's call it strategic science skepticism for the time being. And I think one historically very good example that also helps us to understand this sort of science criticism in the current debates is an example concerning the link between smoking and lung cancer. I mean, in the mid-20th century, there were alleged experts, partly paid by the tobacco industry, that called into question this link between smoking a lot of cigarettes and getting lung cancer, and a result that was well established in medicine. And they did so, they called these results into question in order to promote the financial interests of their funders, namely the tobacco industry. It's hard to sell a lot of cigarettes if people honestly believe it's not good for them. Yeah. So that's work that's been done mostly, or to describe cases of this, if you're interested in this, by historians of science. I just want to name two. I've already named two, actually, Naomi Oreskes and Eric Conway. Their famous book, The Merchants of Doubt, is certainly a very accessible survey of these examples of science criticism. And another kind of much more scholarly piece of work is from another historian of science, Robert Proctor, who has written a book called The Golden Holocaust, that focuses on this particular historical example, the cigarette case or tobacco case I have mentioned just a minute ago. Yeah? And I think in both crises we are interested in, the corona crisis and the climate crisis, you can certainly find many instances of strategic science skepticism. And I think it's interesting to see, I don't know what you think about this, Martin, how more and more cases come up in the current corona crisis day by day, basically.
Yeah, absolutely. I agree. So if one wanted to look in more detail in the way in which the science is, the skepticism is actually working, can one find some typical manifestations of that, what you call strategic science skepticism, how it plays out in detail?
Yeah, so I think there are a number of very typical manifestations or skeptical strategies, if you want to call them that, that one can easily recognize and also identify. Yeah. So let me just mention a few. So one is, and maybe you can just, I can just check whether you can, what you think about when you hear these strategies. So one that you find very often is what one might call cherry picking the empirical data that scientists have gathered. Yeah?
I guess one memorable example from the political sphere is Donald Trump's famous insistence that global warming is a hoax, because on a particular day in Washington it was snowing in May. So he cherry-picked his data for saying global warming is a hoax.
That's right. I mean, that's exactly one of these examples. And another very common manifestation of strategic science skepticism, or strategy to conduct it or to carry it out, consists in a biased choice of how you set up your experiments, what kind of instruments or animals you use. That's a second manifestation. What does that make you think of?
Yeah, that makes me immediately think of one famous example that is often cited in the literature, that there was a certain pesticide, let's just call it XYZ for simplicity's sake, and it was unclear whether that pesticide makes humans sick. And the company who had a financial interest in insisting that XYZ is not dangerous to humans got a bunch of scientists together and financed them who would test the danger of that pesticide, not by using humans, but by using rats as a model organism for humans. And surprise, surprise, the rats stayed healthy and happy despite the exposure. So obviously the rats did not get sick. The scientists and the company, of course, wanted to conclude from that, well, therefore there is no danger to humans. However, it later turned out that the scientists had chosen a particular breed of rats, of which it was known in advance that it would not be adversely affected by this type of pesticide. So that would be a very problematic way of designing one's experiment so that it has the desired outcome.
Yeah, that's right. I mean, that's exactly, excuse me, one of these famous cases. There's actually a third kind of strategy that is a sort of umbrella term for a lot of things, and one might call that manipulation of statistical analysis. And maybe you can give an example, and I can add one. Or
yeah, of course, that's, one could almost imagine us sometimes doing a special video just on those different ways of cheating with the statistics, because of course that's a topic that interests many philosophers. So let's just choose a simple example that one can understand without going too much into any mathematical issues. Usually when you conduct an experiment or you make observations, you can plot your data in a coordinate system. But of course, scientists are never just happy with having a cloud of different points in their coordinate system. What they rather want is they want to reduce the many different points to a nice, clear curve. They want to, as it said in the trade, smooth out the data so that it forms a neat curve. But this curve fitting, ignoring certain data and getting the nice smooth curve, can be done in different ways. And depending on how you decide to construct the curve, certain data can just simply end up being ignored and other data highlighted.
That's right. And let me just, without going into any details, kind of another famous case is so-called p-hacking. But I'll just leave it at that and get to a final kind, which I personally find is kind of philosophically very interesting, and that consists in a biased choice of the concepts you use in order to do your research or to describe the results of your research.
Yeah, of course, there again one can think of many cases, of many complicated cases, but just so to help our viewers to get a clear, memorable example in place, just think of a questionnaire study that forces all subjects that answer the questionnaire to self-identify as either male or female. because thereby one would make third genders or trans people simply invisible as a separate category. And of course, we could think of much more complicated cases, but just to get something to get going to see how that works, let just this example suffice.
That's right. So, I mean, we talked about different strategies or examples, manifestations of strategic science skepticism. So that's one thing, right? To analyze, collect, describe these different manifestations. Quite another is to evaluate these different strategies, right? To analyze what might be worthy of critique, what might be wrong with these kinds of criticisms. And indeed, quite a number of people in science studies, so philosophy of science, history of science, and sociology of science, have proposed certain analyses of different manifestations of science skepticism. And I just want to mention this work here, flag it, that people know what the options are to actually criticize this type of science skepticism. Yeah, so one option is that to assert or to criticize that what the science skeptics are saying simply is unscientific. Yeah, it's pseudoscience. So that follows, so to speak, in the footsteps of Popper's famous demarcation problem, one might say. Yeah, that's one analysis. Another analysis consists in saying, well, the skeptics actually know or have a lot of evidence about what is true in a particular subject area, but they deliberately ignore the truth and they're lying to a public that doesn't have the expertise to recognize what's actually true in a certain case. Yeah, so the best case for that might be the case we already talked about, this tobacco case, where it was pretty obvious to the tobacco industry what was true or what there was good evidence for, but nonetheless they chose to lie about it, basically. Yeah, the question is, does that fit all interesting cases? Another analysis consists in saying that we shouldn't really take seriously what the science skeptics are saying, because they are in stark disagreement with the experts, with the expert consensus, to be precise. So that places an emphasis on social aspects of scientific knowledge generation, consensus of experts. And maybe a last analysis I'd like to mention is that's less socially minded. You could say what's wrong with the skeptics' claims is that these claims are not well supported at all, not well justified at all in light of the given empirical data that are available. Yeah, those are 4 of many analyses that people in science studies have put forth in order to critically analyze these manifestations and other manifestations of strategic science skepticism that we talked about and illustrated with nice examples.
Mm-hmm. Do we have to choose between these options? Could different ones be true in different cases of science skepticism, for example?
Well, I think that sort of depends a bit on your philosophical temperament. So I, for myself, would say it would be really nice to have an analysis that covers all interesting manifestations of science skepticism. I personally think it's the 4th one. But I think I would be happy if it turned out that this is not the case. Yeah, that you simply have different analyses. These analyses, all of the analyses tell us something interesting about some manifestations of climate science, strategic science skepticism, I mean. But none of the analyses covers all interesting cases. But if we take all of the analyses stemming from science studies together, we cover a lot of ground. So if that's the emerging picture, it's not one analysis, but many that serve the purpose of covering a lot of ground, I'm happy to. Yeah.
Okay, perfect. Let's stand back a bit from the details and remind us of our overall concerns so that we don't lose sight of the overall forest by just looking at the particular trees. So we have been looking at different forms of science criticism. Forms of science criticism we all encounter today with respect to COVID-19, with respect to climate science, with respect to vaccination and many other areas. Of course, the list that Alex has proposed that we have discussed is not complete. We have, for example, said nothing specifically about forms of criticism that focus on claims such as that a particular science or a particular scientific theory carries biases concerning race, gender, or sexual orientation. Maybe some of these cases fit into the boxes we already have, perhaps not. That's certainly something to be explored together in the future. In conclusion, I want to suggest maybe one other axis to sum up what we have been talking about. And this is that there are different responses to scientific information. Think of a line and let the line represent the spectrum of responses to scientific information. At one end, we might say, at one end, we have the extreme of total and naive uncritical trust. And on the other hand, we have radical skepticism about science as a whole. And then in between, we have what we might call a natural, healthy critical attitude. We might have selective criticism about certain areas, not others. And maybe we have some other forms that fill in this spectrum between the two extremes. Now, our problem as citizens in today's world is not only that we have to form a view about science. In other words, we have to place ourselves on the scale somewhere, but we also have to respond to other people in the public domain who already have placed themselves somewhere on this scale. So we have like a double response to the scale, place ourselves in our response to science and try to understand and evaluate these different positions that are already on the scale, if you like. Now, the first thing I would like our viewers to appreciate and to see as one of their take-home messages, if you like, is that all this is very difficult. There are no quick and easy fixes on how to respond to the plethora of positions and that we find in public debates, especially when it comes to such highly topical cases of science in the making, as is the case of COVID-19 or as is the case of climate science. One thing this calls for, this science in the making, is a certain kind of humility, if you like, a kind of intellectual humility as an intellectual virtue. That is the attitude of not to jump in with quick fixes and solutions just because the quick fix or solution would make us feel better. Just think, if you like, as an example of this, of President Trump's comments about injecting disinfectant. That's not intellectual humility.
That's right. I mean, I agree with this, that this is, it's certainly it's worth emphasizing, yeah, that this is a very complex and complicated matter. But I think kind of in this conversation, we should also, while recognizing that, also try to give some more positive general orientation. And I have at least one suggestion about this. So one and that kind of is really a follow-up to what you said and to the scale you presented and to the four kinds or categories of science criticism we talked about. So, I mean, if you are a non-expert in science and you encounter some sort of criticism regarding science, I think the first thing to really find out is in what sense that we talked about on your scale or according to these four categories, what kind of criticism is it? What kind of critic is presenting this criticism? How far-ranging is the criticism? Is it all or nothing? Is it about a particular piece? Is it a kind of strategic science skepticism case or something else? I think if you figure that out, you already know a bit more about the situation than you did before. Yeah, I think that's one general thing to suggest, I believe.
Yeah, I agree with that. It's also useful to take away from the examples that we have cited before that give some weight to numbers. So if you have a certain claim A that is criticized by a critic, ask yourself, is this critic an expert in the respective science? Is he an expert from another field? How well supported in the broader scientific community is this kind of claim? In other words, and to repeat a point we have made earlier, distrust people who declare themselves revolutionaries in order to make their minority view more acceptable. And look carefully at alleged experts' field of expertise. Of course, sometimes an outsider to a field X is able to help in solving problems that X is facing. But do remember, this is the rare exception, not the rule. Moreover, it may be obvious to many of our views anyway, but perhaps it is worth repeating, draw on several sources of information, newspapers and TV channels with different political orientations, and compare the experts the different channels or newspapers parade onto your screen or parade onto your page.
Yeah, and let me add two more things to this list, maybe, of general orientation items. So one is, I mean, I've also experienced that myself in the current crisis, at least on some days. Sometimes you just feel you're overwhelmed by all the information you get. Yeah, but I think the right response, and that is understandable, but I think the right response to that is not to say I'm overwhelmed, therefore I don't trust the science or I call it into question, but the right response to that feeling of not being able to process all of that information is to suspend judgment, at least for the moment or for the day. Yeah. And I think that's not really some kind of intellectual embarrassment because these things are really complex. I think it can be a form of intellectual courage to say, I can't really form an opinion about this now. I need more time for this, for instance, and that's totally legitimate, I think. And a second thing I would like to add is, and it might seem obvious, but I still want to say it. You said one should consult different sources on a particular problem. I agree with this, but I think one should emphasize that these sources should include the obvious places, the obvious outlets of scientific information or the relevant scientific institutions in the situation. So for instance, if it's about the corona crisis and you live in Germany, one of the first places to consult or to check or to get information from is the Robert Koch Institute or the World Health Organization. And what they say about how the virus spreads, what they say about certain myth or items of misinformation, false information. And I think one does get a lot of very precise and easy to understand information from these natural sources you should turn to in the first place. Yeah.
Mm-hmm. Great, Alex. Thank you so much. I'm afraid we have to leave it here. I hope we have been able to convey to you, our audience, some of the philosophical and sociological complexities of experts and assessing experts and scientific knowledge in our present day situation. We hope to make many more videos such as these, and to repeat, if you have comments, suggestions, or ideas for what our programs in the future might focus on, then please let us know. But for today, thanks so much for being with us, and we hope to see you for another video soon. Thanks again, Alex. Bye-bye.
Thanks, Martin. That was fun.